Hello everyone. So in this video we are going to see about integration. Until now we have seen the differentiation and now we are going to see the integration. So now we are going to see integration, some basic functions, how to integrate, and then we are going to see examples on basis of that and rules of integration and examples on basis of that also. Okay. So we're going to solve lots of examples and let's start. Okay. So what we are saying about integration is that integration is just basically the opposite of differentiation. So if I am saying that there is a function yx is, and you differentiate and you get some gx, okay, then if you integrate this gx you will get the yx. That is the basically integration is, okay, just the reverse of differentiation. Okay, so how we denote this? We denote by this symbol and then y dx. Okay, so integration of y dx. Okay, so you put whatever y it is given in terms of x and then you integrate. Now we're going to see some basic standard functions of integration. Okay, it is easy to remember if you remember the differentiation. Okay, so this, see the second one. If you have sin x differentiation, what you write? Cos x, right? So cos x integration will be sin x plus c. Why we write plus c is because if you differentiate sin x you are getting cos x, right? But if you differentiate sin x plus some constant value, then also you are getting cos x only, right? So for the broad case, like it is possible to there is a constant or not. Okay, for that calculation there will be further information given in the question for calculating this constant. So maybe this constant is 0, but maybe it is not 0, right? So for a vast case we take c, and then on the basis of the information given in question there may be a coordinate given. According to that we calculate the c value. Okay, we will see questions on that, don't have to worry. So sin x integration will be minus cos x integration will be sin x, e to the power x integration e to the power x plus c, 1 by x integration ln x plus c. So ln x differentiation is 1 by x, so 1 by x integration is ln x plus c, x to the power n, x to the power n plus 1 divided by n plus 1 plus c. So if you differentiate this function you will get x to the power n. Okay, and here k integration kx plus c, sec square x, tan x plus c, cosec square x minus cot x, sec x into tan x, sec x plus c, cosec x into cot x is minus cosec x plus c, sin ax plus b, that is minus cos ax plus b divided by a plus c. Okay, and similarly cos ax plus b, and these all same thing. Okay, now let's do some questions based on this. Okay, now let's start with y equal to x square. So for a part, if we do integration y dx, put the value, what is y given? X square, right? So when you integrate, remember this thing, if you are integrating with respect to dx, then the function which you are integrating, it should be in one variable, that is x only. Okay, if you are integrating with respect to y, like dy is there, so the whole function will be in y. Okay, here y dx is written, so y is another variable and x is another variable. So you have to replace this y in x terms, and we know y is equals to x square. So here if you integrate x square dx, that is, if you see x to the power n, what is the integration of x to the power n? X to the power n plus 1 divided by n plus 1. Let's write down x to the power n plus 1, 2 plus 1 divided by 2 plus 1. So that is x cube by 3 plus c, always remember, plus c. Okay, let's do the b part. Okay, b part similar. X to the power 3 by 2, integration of x to the power 3 by 2 dx. So what it will be? X to the power 3 by 2 plus 1 divided by 5 by 2, I can say, right? So this will be 2 by 5 x to the power 5 by 2 plus c, or here also plus c. Okay, let's do the c part. C part I can say 1 upon 1 by root x. So c I equal to integration of x to the power minus half dx. So if you integrate you will get it 2 root x plus c. Okay, d part, if you see d part, so 1 upon x square, so what it will be? I equal to integration of x to the power minus 2 dx. Okay, so x to the power n plus 1 divided by n plus 1, so it will be x to the power minus 1 divided by minus 1 plus c, so that is minus 1 by x plus c. Okay, then let's see e part. What is e part? E part is I equal to integration 4 dx. Okay, so we know the constant integration will be 4 into x, so 4x plus c. Okay, this is your answer. Okay, now this is simple integration. We have mostly seen the x to the power n things. Okay, other things you will see here. Okay, so now we will go for the rules of integration. Okay, now in rules of integration, first rule is addition and subtraction, same as the differentiation rule. Okay, what we do in differentiation, we will separately differentiate, right? Here also we will separately integrate. If someone says us to integrate the y, we will separately integrate the two functions. Okay, so here I will integrate fx separately and gx separately. Okay, and so let's see the some examples. Okay, better you will understand with the examples. So what are examples? Y equal to sin x plus cos x. Okay, so here y equal to sin x plus cos x. So if you integrate y dx, so what we gonna do? We will integrate separately sin x dx plus integration cos x dx. Okay, so what is the integration of sin x? We know minus cos x plus cos x integration sin x. Okay, plus 1c. So both will have constant, so I replace both constant with one constant. Okay, c1 plus c2 equal to c. Okay, like that. Okay, so here let's do the another question. I equal to this integration, so we can separately do the integration x cube dx plus integration cos x dx. Okay, so what we're gonna see here, x cubed integration, we know x to the power 4 by 4 plus cos x integration sin x plus c. Okay, now let's see next integration. I equal to integration sec square x plus integration dx by x. Okay, so 1 by x, that is only here, sorry I forgot dx. So sec square x dx, so that is 10x plus ln x plus c, don't forget the c. Okay, now let's go ahead. Next rule is, I hope this you understood. Next rule is constant multiplication rule. Okay, now what is constant multiplication rule? Same as differentiation only. Okay, so what we take, if the k is a constant, it is not a variable thing. Okay, first you have to fix that the k is constant, then only when you will put the integration sign both the sides. Okay, then only you will able to take k out of the integration when the k is constant. Okay, always remember. Okay, now if a constant is multiplied to a function during integration, the constant will come out of integration. So this is something like this. When you will integrate both sides, what you will write, y dx equal to integration of k fx dx. Okay, so you will take this k which is in multiplication outside when this is not dependent upon the dx. Okay, then only you can take, otherwise it will be also integrated with it. Okay, you have to find out the integration of this whole function. Now let's do the question. Okay, some standard questions. What is written? Y equal to 2 sin x. So what can I write? I integration, 2 is a constant, so I can take 2 outside, sin x dx. What is the integration of sin x? Minus cos x. So this will be minus 2 cos x dx, cos x plus c. Sorry. Next thing, x cube by 3. So 1 by 3 is a constant, so I can integrate x cube dx. Okay, so what can I say? X to the power 4 by 4, so that will be x to the power 4 by 4 into 3, 12 plus c. Okay, now see, this is a part, this is b part. Let's see the c part. What is 3 by x to the power 4? So you can take 3 outside, and this will be integration of x to the power minus 4 dx. Okay, that will be how much? I can say 3 into minus 4, sorry, just x to the power minus 3 divided by minus 3. So this plus c. So this will be minus 1 by x cube plus c. Okay, and next is sin x plus 2 cos x. So we can apply addition rule. So addition subtraction rule. So addition rule, by what can say, we will integrate them separately, and then in this you apply the constant rule. So sin x dx plus 2 outside cos x dx. Okay, so sin x integration, we know what is sin x integration, minus cos x. Okay, plus cos x integration sin x, so 2 sin x plus c constant. Okay, Now let's see next question. Okay. What is given? Differentiation of a function fx is gx equal to 3x square. Okay. Then find fx if at x equal to 0. So what is given? What he is saying that fx. So when you will integrate gx, you will gonna get fx. That is he is saying. Okay. Because when you are differentiating fx, you are getting gx. Okay. So when you will integrate the gx, you will get fx. That's what. Okay. Now what he is saying, gx value he gave us 3x square dx. Right. Now let's integrate. What you got? Fx equal to x cube by 3, 3 into x cube by 3 plus c, right? X cube plus c. This is your fx. So fx equal to what you got? X cube plus c. Now see here, I told you that for calculation of c there will be some value given. So what is given here? That at x equal to 0, f of x is 4, right? So what is given? F of 0 is given 4. So you put this value here. So what you will get? You will put the value, then you will get 4 is equals to 0 cube plus c, right? So that is c equal to 4. So what you got? Fx, your final answer, that is x cube plus c, you got 4. So plus 4. This is your final answer, fx. Okay. So for calculation of c, you will be have given the information. Okay. Now next method. Next is substitution method, and this is very important, and most of the questions are asked from the substitution method only. Okay. What substitution method says is that fx fx have gx and this g dash x, that you know, this is standard thing. Okay. Did you remember this thing where you have seen this thing? This is something looking like the chain rule, right? But it is not like that. Okay. How we will do? If the function here is like this, okay, what is here? That fx f of gx into g dash x. Okay. Then what you do? What the hell happens? It is switching to pen. I don't know why. Okay, you can cut this part. Okay, now start. So in substitution method, what we see here is f of gx into g dash x. So if a function, and there is a inside a function given, okay, and then after whatever inside function was there, its differentiation you can see outside. Okay, then you can use the substitution method. You can substitute the gx as t, and then you can solve it. How to solve this? We will see the standard method. Okay, you will see some standard method for that. Okay, so what he is saying is, when you will integrate, okay, you integrate the fx and you will get this. Okay, so f, capital F, whatever integration of outer function into gx. Okay, so when you will differentiate, you will get the this function, right? So now let's see the proof. How to prove this? Okay, in this function, what you want to do, first write down y equal to f of gx into g dash x. Okay, you want to do the integration, right? So let's do the integration. Y dx, that's you want to do, right? Let's do f of gx into g dash x dx. Okay, now I'm saying you that put gx as t. Okay, so you differentiate this. So what you got? G dash x dx is equals to dt, right? This is, I am telling you, this is the substitution thing. This is what? Substitution. Now let's do. Now let's go ahead. Okay, put this g dash x here. So what is your y dx integration came? That came integration of f of t, and g dash x into dx is dt, right? So this came t dt, and we know that f of x dx integration is capital Fx. Okay, so I can write this as capital F of t plus c, right? So what your integration y dx came? Y dx came f of t. So what we assume t? Gx only, right? Let's write down gx plus c. This is your proof. So what we have to do? Whatever, if you are able to see a inside function and then inside you have one more function, but that inside function differentiation is available outside. Okay, then you can use this substitution method, and that, so we are going to see too many questions on that, and you will able to understand what it is, what I meant. Okay, see here, if you see this integration, okay, this integration is not come under the standard integrations, right? So here comes the your substitution method. Okay, now how I will click this, see inside what is written x square plus 2, right? Its substitution is available as outside, x is available, so we can create 2, right? Factor we can create, that is not a problem. Okay, so what I will do, I have y equal to x dot x into sine of x square plus 2. Okay, now what I will do, I will put x square plus 2 as t. Okay, this is my substitution. Okay, so what I got, 2x dx equal to dt. Okay, now let's do the integration. I is equals to y dx. Okay, that is integration of x into sine of x square plus 2 dx. Okay, so here I know x dx is creating x dx, so what is that, x dx is from here is dt by 2, right? dt by 2. So what I got, integration x dx is dt by 2. Let's substitute integration of sine x square plus 2, I assume that is t. Okay, into dx by 2, that the x dx is dt by 2. dt by 2, 2 is a factor, 2 I can take outside integration, so sin t dt integration is minus cos t, right? Minus cos of t plus c, right? So what can I say about minus cos t? Minus cos and t we assumed what, x square plus 2 plus c. Okay, that's all. Now by the help of chain rule you can differentiate, you will get the same thing. Okay, you can try that out. Okay, you will, oh sorry, we forgot the 1 by 2 factor here. Sorry for that, you forgot the 1 by 2. Now you differentiate this function, you will get the same this function. Okay, you can do, try that out. Okay, so this is basically the substitution method. Okay, now let's do some more questions how to do that. Okay, sine of 3x plus 4, this if you see, we have in standard functions we wrote in integration, that there we also wrote sine of ax plus b. Okay, so here we can use the substitution. What substitution we will use? Basically first let's write down integration sine of 3x plus 4, basically the 3 factor which we can resolve easily. Okay, what we will substitute, we will substitute 3x plus 4 as t. Okay, so what I got, x dx is basically dt by 3, right? This is my substitution. Let's write down the I. Okay, what is I? Integration sine of t into dt. So dx, here it will be dx, sorry for that. So this is dt by 3. Okay, so sine t, and that is dx is dt by 3, so dt by 3. Okay, now what I am saying is sine t 1 by 3 factor I can take outside, sine t integration is sine t dt integration, that is minus cos t, so minus cos divided by 3 it was there, and t what we substituted, 3x plus 4, let's take 3x plus 4 plus c. Okay, so you can see here that it is came same as minus of cos ax plus b divided by a, right? That's only we wrote, that only we wrote in the question standard examples also. Okay, here also you can do. So what here I see is the outer function is sine and inside function is cos x, and cos x differentiation I see outside. Okay, minus sign, minus 1, that is factors we can like adjust. Okay, so cos x differentiation is available outside. Okay, so what is my substitution? I will substitute cos x as t. Okay, so what I get, let's differentiate this. So this will be cos x differentiation minus sin x dx is equals to dt, right? So I can say sin x dx is how much? Sin x dx is minus dt, right? This is your substitution. Let's write down the I integration. Integration I equals to sine of cos x, I assume t, and sin x dx is minus dt. So minus sign here I can keep, and dt here. So sin t integration is, here again it became minus cos t, so it's minus of cos of, and t we assume that is cos x. So cos of cos x plus c. This is your integration I. Okay, now let's go for the next question. X plus 5 to the power 5. Okay, how to do this? So we have x plus 5 to the power 5. So what is inside function? Outside function is x to the power n, right? So what can we put? X plus 5 equal to t. Okay, so dx is equals to dt here came. Okay, this is your substitution. Okay, now let's write down the I. I is equals to integration of t to the power 5 dt, right? Dx replaced by dt. Okay, whatever you are integrating here, okay, same function you have to take here also. Okay, you can't keep half of the x and half in t and then you integrate with respect to t or x, not like that. Okay, completely it should be in one variable. Okay, then you will able to integrate. So we know t to the power 5 integration is t to the power 6 by 6 plus c, right? So that is t, what is t value? X plus 5. Okay, x plus 5 to the power 6 divided by 6 plus c. Okay, now let's see next integration. Next integration, how will I do? What I see outside is x dx, right? So x square integration, 1 plus x square differentiation I can see outside, right? So I will assume 1 plus x square is equals to t, right? So I can say 2x dx is equals to dt. Okay, that's what I see. Okay, now let's do how we will do this. Now this is your substitution. Okay, and then I is equals to integration of, here under root of 1 plus x square, 1 plus x square is t, so this is root t, so t to the power half, and then x dx is dt by 2, so dt by 2. Okay, don't forget the factors, otherwise answer will come wrong. So 1 by 2, t to the power half integration is t to the power 3 by 2 divided by 3 by 2, right, plus c. So how much it came? T you can substitute 1 plus x square to the power 3 by 2, and this will be 1 by 3, so 3 will be effect plus c. Okay, so you can try with the differentiation, you can do the differentiation, you will get this. Okay, now let's see the next thing. Next is very good question. So here people can confuse that you substitute cos x minus sin x and then you will getting the same as with a negative sign, you will getting the differentiation, but you will not able to do that. Okay, so what we will do is we will go with the substitution sin x plus cos x equal to t. Okay, you can try with cos x minus sin x also, you will not get the answer. Okay, you can try it out. Okay, you will just not able to completely make the function in t. Okay, that's what I am saying. Okay, so here if you differentiate, what we are substituting is be the below function sin x plus cos x, we are substituting t. Okay, so now let's differentiate. So what we got? Sin x differentiation cos x. Okay, and cos x differentiation minus sin x. Okay, and dx you take common. Okay, is equals to dt. So now if you see cos x minus sin x into dx, cos x minus sin x into dx is dt, right? So we can directly substitute. I equals to integration of, you can say this is above it is dt and divided by t. So 1 by t integration we know ln t. So ln of t, that is what is t? Sin x plus cos x. Sin x plus cos x plus c is there. Okay, so this is your integration. Now let's do this integration. So what can I say? Sin square x into cos x. Okay, so one method is you just expand this inequality, then you will get do something, but we will go with the substitution method. Then also you will substitute only. Okay, if you this expand this and resolve other things, then you will also, but still what we will do here, we will substitute sin x directly. Sin x equal to t, so cos x dx is equals to dt. Okay, now what we got here? I is equals to integration of t square dt, right? I hope this is clear. So t square dt integration, what is t cube by 3? So t cube by 3 plus c. What is t? Sin x. This is sin cube x by 3 plus c. Okay, this is what you get after integration. Next integration, cos square theta d theta. So what we can say here, how to do this integration, cos square theta d theta. First we will substitute, you have to resolve this cos to theta. See, now here outside you don't have any available thing, right? So what you will do, you will reduce the power of this function. Okay, how to reduce the power? Y is equals to integration of, you remember the formula of cos to theta? Okay, by that if you solve, so cos to theta equals to 2 cos square theta minus 1, right? So by that if you get, you will get cos to theta plus 1, you take the 1 that side, divided by 2, this is your cos theta, okay, into d theta. Okay, now this is very much easier. Okay, now you divide this. Okay, how you will do? Integration of cos to theta d theta and 1 by 2 outside. Okay, 1 by 2 outside plus 1 by 2 integration of d theta. Okay, I hope this is understood. Just I divided this both. Okay, now 2 theta, cos 2 theta d theta. So here 2 theta you can substitute t and you can integrate. Okay, I am doing this part little bit faster. How you will do? Cos 2 theta d theta integration. So you will get here sin 2 theta divided by 2 factor will come. Okay, so this is like ax plus b, cos of ax plus b. So you will get factor 2 and 1 by 2 is already there, so it will got 4. Okay, plus d theta integration is theta, so theta by 2 plus c is there. Okay, so this is what you get. I hope this is clear. What we did, we reduce the power. How we reduce? By the cos 2 theta formula. Cos 2 theta equals to 2 cos square theta minus 1. Okay, by that. Now see the next question. Next question is very important question and very good question. This is like standard method we use for solving this question. If anyone have any substitution you can do. Okay, what I will do is, now if there was an x dx, then it was an easy question. Ax square plus a square plus x square equal to t you put, and then you will get x dx above, put it equal to dt. But that is not the case here. Here you don't see a x dx, right? So what you will substitute? Now you will use a trigonometric ratio. Okay, what I will do, I will substitute x equal to a tan theta. Why I substituted a tan theta? So that I will create, if I substitute here a square tan square theta, right? So what it will become? A square you take common, then 1 plus tan square theta. So 1 plus tan square theta is identity, right? So by that I can resolve it. Okay, let's see. If I substitute, what is the dx value coming? A tan theta differentiation, that is sec square theta d theta. Okay, now let's resolve the integration. I is equals to integration of dx, that is a sec square theta d theta divided by a square to the power 3 by 2 multiplied by 1 plus tan square theta to the power 3 by 2. Okay, let's do the integration. So this is, if you do it with a cube, so 1 by a square. Okay, this is like you can say constant, so it will come outside. Okay, let's do sec square theta d theta divided by 1 plus tan square theta is sec square theta, so 2 to power, so this will become sec cube theta. Okay, so what it became, 1 by a square outside, integration of 1 by sec. So 1 by sec is, I can say cos theta d theta. Now cos theta d theta integration we know sin theta, right? So I can say this is sin theta by a square plus c, right? Now we know from here, this is my substitution. Here we know tan theta is x by a, so I can calculate the value of sin theta and I can put, because I can't answer in the sin theta terms, I have to answer in x terms, right? So I will do that. So if tan theta is x by a, perpendicular upon base, right? So this is perpendicular upon hypotenuse. Okay, so I can answer that. So x divided by a square minus x, a square plus x square, right? So this is a square under root of a square plus x square, right? Plus c is there. This is my final answer in terms of x. So there is a like standard method to solve this question. What was that? You substitute this x square with what value? You will substitute this x square with a tan theta. Why I have substituted with a tan theta? So that I can take a square common, it will become a square, and I will take it common, and 1 plus tan square theta will become identity, so that I will able to resolve it. Okay, and above also I can directly differentiate dx as this thing. Okay, so these are standard method. If there was an a square minus x square, then how you did it? A minus x square, a square minus x square, then how you did it? You have substituted it a sin theta, and by a sin theta you can get the answer, right? Again this pen is not working. Okay, it came. Next question. Okay, what is the next question? X dx. So I think this question is easier than the above. Okay, what is the I? I'm not able to write. You can edit this part. There is a lag. I don't know what the hell this want to do one note. In one video it happened twice. Yes, it came. Okay, so this is integration of x dx divided by 3x square plus 2 to the power 3 by 2. What I will substitute here? I will substitute here. It is not working. Okay, just edit this part and let's keep it till here only. Okay, you can edit the last part. Thank you everyone.